In order to navigate our everyday social environments, we often have to assess the relationships, affiliations, and dispositions of people around us. Who cares about who tends to be selfish, who tends to be pro-social, and so on. Throughout this talk, I'll use the term social preference to capture this notion of how one cares about others relative to oneself. An important cue to someone's social preferences are the social choices they make. These are choices where the outcome directly affects someone other than just the chooser. For example, suppose Pat enters the office break room and sees a box containing 1 jelly and 2 glazed donuts. Pat's coworker Linda doesn't have her break for a few more minutes, so Pat gets first pick. What donut will Pat choose? Intuitively, we should expect Pat's choice to depend on several things. Of course, it will likely depend on whether Pat prefers jelly or glazed donuts, but notice that Pat's choice may also affect Linda. If Pat takes the only jelly donut, then Linda will not get a choice, as there will only be glazed donuts remaining. Thus, we might expect that Pat's choice also depends on which donut Pat thinks Linda prefers, as well as how much Pat cares about Linda. For example, if Pat and Linda both like jelly donuts, but Pat really doesn't care about Linda, Pat might take the jelly without a second thought. On the other hand, if Pat cares a lot about Linda, he might take one of the glazed to make sure that Linda gets what she likes best. As this example suggests, previous work has shown that humans draw on our intuitive theory of mind when making judgments in a social context. That is, when making judgments about an agent's social choices, we are sensitive to the agent's personal preferences, their beliefs about the preferences of others, and the agent's social preferences about other agents affected by the choice. That said, most existing work on social judgments like these considers scenarios where the chooser has full knowledge about other agents' preferences. In real-world social situations, however, we often have to work with incomplete information or even total ignorance about the preferences and beliefs of other agents. This raises the question, how do we reason about social preferences and social choices in the face of such uncertainty? While there hasn't been much computational work exploring social inference under uncertainty, there is some experimental work in social psychology exploring our judgments in similar cases. This research suggests that people tend to associate pro-social attitudes with actions that maximize the number of choices available to the other agent, a phenomenon known in the literature as the social mindfulness effect. However, it is not clear that leaving the other agent more choices should always be considered socially mindful. Suppose, for example, that Linda is extremely allergic to the type of fruit used in the jelly donut. In this case, allowing Linda to choose the donut that would make her very ill may not be perceived as a socially mindful action. With this in mind, we argue that this social mindfulness effect, as well as more general inferences about social preferences, can both be explained with a common utility-based model, which allows for varying degrees of knowledge or uncertainty about other agents' preferences. By incorporating this uncertainty, our model is able to capture a broader set of social predictions, and can explain the social mindfulness effect as a special case of utility-based reasoning. Now I'll explain our computational model. The core assumption underlying our model is that agents act rationally to maximize their utilities, the differences between the costs they incur and the rewards they achieve. This rational utility-maximizing framework has been tremendously successful in recent years at explaining a wide range of cognitive phenomena, and has more recently been applied to social inference as well. In the context of social choices, which directly affect another agent, we need to account for the fact that one agent's total utility may depend in part on another agent's utility. That is, if I care about myself but I also care about you, then the total utility I get from my decision should depend on the utility I personally get, as well as the utility that you get from my decision. To illustrate this more clearly, we consider variations of a donation game, in which an agent starts with an allotment of goods and has to give a certain amount of those goods to another agent. Throughout this talk, I'll refer to these agents as giver and receiver, respectively. Following previous work, we capture this notion of interdependent utilities by defining the giver's total utility as a weighted sum of the utility that giver derives directly from the outcome of their decision and the utility that receiver derives from the outcome of giver's decision. Note, however, that the latter term is really giver's belief about receiver's utility, as giver cannot directly observe receiver's utility function. These two weight parameters specify giver's social preference with respect to this particular receiver. if we restrict these parameters to the values -1 and 1, we can associate each point in this box with a different social preference. For example, a purely selfish giver corresponds to a self-weight of 1 and an other weight of 0, while a purely altruistic giver corresponds to a self-weight of 0 and an other weight of 1. Joint utility functions like this have been used to model human social judgments about social choices. However, this equation assumes that receiver knows receiver's utility function exactly. As we raised in the introduction, humans often have to make social judgments or choices with little to no information about the preferences of others. So how can we model social judgments in a case like that? To capture this, we generalize the model by representing a giver's belief as a probability distribution over receiver's possible utility functions. If giver is fully ignorant of receiver's preferences, this will likely be a uniform distribution over all possibilities. However, we can also represent partial uncertainty. For example, if giver is fairly certain that receiver likes jelly more than glaze, but giver isn't certain and doesn't know the strength of this preference, we can capture this with a probability distribution that is skewed towards higher utility values for jelly rather than for glazed. We then define giver's total utility as a weighted sum of giver's direct utility and receiver's expected utility according to giver's belief distribution. With giver's utility function defined, we can model social judgments using Bayesian inference. For action prediction, we make the standard assumption that giver is more likely to make choices with higher total utility, according to a softmax function as shown on the right-hand side of equation 2. An observer can use this equation to predict giver's choice based on some information about giver's social preference. For inference, we can apply Bayes' rule as shown in equation 3. This allows an observer to infer giver's social preference after seeing giver's choice. Thus, we can use these three equations to make graded predictions about human judgments in a variety of social scenarios. Now we'll discuss the two experiments we ran to test these predictions. Both of our experiments share a common stimulus form. Each stimulus depicts a named giver and receiver, the giver's initial allotment of two types of treats, and the number of treats that giver must give to receiver. We depict information about giver's preferences and beliefs using thought bubbles like these. The thought bubble on the left will either specify a preference for one treat over another, or a preference that values both types of treats equally. The thought bubble on the right will either specify a belief about receiver's preference, or it will specify that giver is fully ignorant of receiver's preference. In study 1, we asked participants to predict giver's decision based on some information about giver's social preference. We designed 9 different variations of the scenario shown here, and for each stimulus we asked participants to predict giver's decision under 3 different conditions. In the selfish condition, we specify that giver mostly values their own preferences. In the altruistic condition, we specify that giver mostly values receiver's preferences. And in the egalitarian condition, we specify that giver values their own preferences and receiver's preferences about equally. In all 3 conditions, we ask participants to predict which 2 treats giver will give to receiver. Our results show that overall, human judgments were strongly correlated with model predictions. However, the correlation was much stronger in the altruistic and selfish conditions than in the egalitarian condition. We have some thoughts on the source of this discrepancy, but in the interest of time, I will leave that discussion for the Q&A. That said, Study 1 does replicate the so-called social mindfulness effect, but it also shows how this effect is clearly sensitive to giver's beliefs and is not always about taking the action that preserves the receiver's choice. To illustrate this, let's look at 2 versions of the same condition, which differ only in terms of giver's belief state. In the no-knowledge condition, giver is fully ignorant of receiver's preference. Previous research suggests that in a case like this, people associate pro-social preferences with actions that maximize receiver's available options. In this case, participants should expect an altruistic giver to take a brownie so that receiver gets one of each type of treat, and participants should expect a selfish giver to take a cupcake, leaving receiver with 2 brownies. Indeed, our results show exactly this trend. Participants expect the altruistic giver to give one of each type of treat, and expect the selfish giver to give 2 brownies, keeping the cupcake for themselves. Now let's look at the partial knowledge version of this trial, where giver believes that receiver most likely prefers brownies. In this case, we see the social mindfulness effect disappear. In all three social preference conditions, participants expected giver to keep the cupcake and give both brownies to receiver, even though this choice reduces the number of options available to receiver. Thus, in addition to capturing participants' judgments about social choices, this provides evidence for our hypothesis that social mindfulness is about enabling other agents to maximize their utilities, rather than directly maximizing the number of choices available. In the second study, we investigate the reverse problem. Can participants infer the giver's social preference after observing the giver's decision? The stimuli and conditions we used for this study were nearly identical to the stimuli from study 1, but also depicted giver's choice in each trial. We then asked participants to indicate how much giver values their own preferences and how much they value receiver's preferences on two separate sliding scales. The results of this study show that human judgments were strongly correlated with model predictions for both the self-weight and other weight parameters. Furthermore, Study 2 provides additional support for our hypothesis about the social mindfulness effect. To see this, let's once again compare two sets of trials that differ only in terms of giver's belief. The first pair of trials depict a no-knowledge condition. In this case, previous research suggests that the giver on the left, who gives two identical treats to receiver, should be perceived as more selfish, while the giver on the right, who gives one of each treat, should be perceived as more altruistic. As we see here, both model and participants made inferences consistent with this prediction. Now let's look at the partial knowledge version of this trial, where giver believes that receiver likes brownies more than cupcakes. While the giver on the right is still perceived as altruistic, the giver on the left, who gives away both brownies, is now perceived as caring about the receiver and themselves about equally. This provides further support for our hypothesis that social mindfulness is perceived in terms of expected utilities rather than the actual number of remaining choices. Now I'll wrap up with a summary of our conclusions and some future directions for this research. Our utility-based model builds on past work by allowing us to represent varying degrees of knowledge or uncertainty about agents' preferences, and our two experiments provide converging support for this model. Our first experiment demonstrated that when an agent's social preference is known, human predictions about social choices strongly tracked with our model. Our second experiment demonstrated the converse, that participants' inferences about social preferences from social choices again strongly tracked with our model. Furthermore, these experiments provide converging support for our hypothesis that social mindfulness is perceived in terms of enabling other agents to maximize their own utilities, rather than in terms of maximizing the number of choices available to other agents. We demonstrated that the social mindfulness effect holds even when the receiver does not explicitly get a choice, and that the effect is sensitive to the giver's level of knowledge or ignorance about the receiver's preferences. While these results are promising, there are many remaining questions to be explored. First, while our model closely tracked human judgments across a wide range of scenarios, the most significant discrepancies occurred when predicting egalitarian choices. It is possible that humans simply reason about egalitarian social preferences in a fundamentally different way than selfish or altruistic preferences. However, we believe this effect is largely due to the ambiguity inherent to many of our egalitarian trial conditions, and we will require further research to disentangle these possibilities. A more general limitation of the current model is that it considers these donation game scenarios outside of any broader social context. In reality, there are numerous contextual factors that can shape and influence social inference. One factor of particular interest are concerns about reputation or peer pressure that arise when some third party gets to observe the giver's decision. A second important factor that can influence social judgments are intergroup dynamics and group associations. Accounting for this group structure and other social contextual factors is an important future extension for our work. Thank you for listening, and thanks also to my collaborators, as well as the CSC and SCD labs for their feedback and support.